Alright, so this video is going to be all about making dilutions. So first off, what is a dilution? It is essentially when you take a solution and then you add solvent to that. So you're going to add some water in. Okay. And when you do that, when you're going to add that water, what it really does is lowers the concentration. Okay. And you guys have seen this a lot of times before. Just imagine you're making something like Kool-Aid and you first put it in, there's a lot of sugar and not a lot of water, so it's got that really dark, deep red color. And what's going to happen is as you add water over time, it's going to become lighter and lighter. Okay. So when you're doing that, you are just diluting a solution. Okay, the really one big key here is that the number of moles is going to stay the same, but the volume is changing. Okay, we're not adding any solute, we are just adding some solvent in there. Okay, so there is an equation for this, and that equation is that M1V1 is equal to M2V2. Okay, so this M1 right here, that is going to be your original solution, and that is going to be the concentration, that molarity. And then V1 is going to be the volume in liters of that original concentration. Okay. And then M2V2 is going to be the same thing. It is a concentration and volume for whatever you're trying to get to in the end there. Okay, so let's look at a couple example problems. So this one says, how many milliliters of 2 molar magnesium sulfate solution must be diluted with water to prepare 100 milliliters of 0.4 molar magnesium sulfate? Okay, so whenever I start these problems, I always like to label everything that's in there. So the first thing here is going to be our volume. That's what we're looking for. It says how many milliliters. It also gives us 2 molar magnesium sulfate. That's going to be a concentration. And it says this must be diluted. Okay, so that means that these are going to be M1 and V1. Okay, so that is what you're starting with, what's being diluted. Okay, and then over here it says that we have 100 milliliters, that's going to be our V2, of 0.4 molar MgSO4, so that's M2. So another reason you can tell too is that this is 0.4, so that must be what is diluted because it is less than the original 2 molar concentration. So that's another way you can tell that that's going to be the V2 there. Okay, so pretty straightforward. We're just going to use this equation, M1V1 equals M2V2, and we're just going to get our algebra on here, plug in some numbers. So 2 molar for M1, we're looking for V, looking for that volume. That gives us 0.4 molar, and then a volume of 100 liters, or milliliters, excuse me. Okay. So we're just going to multiply that 0.4 by 100, which will give us 40. I'm sorry, no milliliters there. And we got that 2 volumes, so we're going to divide by 2, divide by 2. So that means that original solution of the first volume was 20 milliliters. Sweet. And it is 1 sig fig there, matching the 100 in the equation to start. Okay. Second one, almost identical to the first. It says how many milliliters of a solution of 4 molar potassium iodide are needed to prepare 250 milliliters of 0.76 molar potassium iodide. Okay, so same thing, we're just going to label everything in the equation to start. So it's looking for milliliters. Again, it's looking for V1. It gives us a molarity, gives us V2, gives us a second concentration. So M1V1 is equal to M2V2. Same thing as before, guys. We're just going to plug in all those numbers. Okay, 0.76 for that molarity, 250. Okay, so we multiply those two together, and we're going to get 190. We get 4V is equal to 190. Divide both sides by 4 again. We want to get that V by itself. So that V1 is going to be equal to 47.5 milliliters. Okay, the sig figs aren't right there. It would be 50 rounding to sig figs. Okay, and our last question here is a little bit different than the first two. This one says, how could you prepare a solution? And then it gives you some kind of details there. So this one's different because it actually wants the lab directions, like physically, how would you do it? How could you prepare this solution? Okay, so that's what makes this one different. Okay, so in this, it gives us a 250 milliliters, so that's going to be our V2. And it also gives us 0.2 molar of the NaCl, so it's going to be our M2. And we know that that's the V2 and M2 because that is going to be our final solution. That's what you're trying to prepare. It actually really doesn't matter if you make it M1 and V1, you'll still come out to the right answer. But technically it should be M2V2 because that's what our end goal is, and that's what we're trying to get to. Okay. Another way you can tell too is when we're looking at this 1 molar NaCl, so that's our M1, and it wants to know how much water we're going to add in. So the M1 has to be the original solution because that's where you're adding water to, and it also has a higher concentration than the 0.2, so that one's not the dilution. The 0.2 is the dilution. Okay. So we're going to start out like those other questions, and we're just going to do that dilution law. So M1V1 equals M2V2. Okay, and we're just going to plug in those numbers just like before. Okay, multiply them together. And we're going to get 50 milliliters for our volume 1. So what that means actually is that is the volume that we are going to start with. So that is going to be the volume of that NaCl original 1 molar solution. Okay, so the directions in terms of lab would be to start with 50 milliliters of 1 molar NaCl. Okay, and now for the second step, right, to make a dilution, you need to add some kind of water. So that is going to be the second step here, is going to be add in water. We don't know how much, so we're just going to leave that blank and fill it in later. Okay, so what do we know about volume 2? We know that it is 250 milliliters, and that comes from the original question there. Okay, so I think the easiest way to think about this is to draw a picture. So the whole volume of what we're going to end with is 250. Okay, and we know that we are going to start with a volume 1 that is 50 milliliters. So that's going to be this bottom part here. That's 50 milliliters. So if we're starting with 50 milliliters and we need to get to a total of 250 milliliters, how much water do we need to add? I'm just going to color this in right here so you can visualize it a little better. That's going to be the water portion of our solution. And you can kind of see it's just the easiest subtraction. So if we need to end with 250 and we need to get rid of 50, that's just 200 milliliters of water. So last thing here in this image, you can really see the visual of what's happening inside the containers. So beforehand, there's a lower volume, which means there's a higher concentration. If you look at all those little red molecules in there, those show that they're really close together, so there's a lot of solute And then on the right side, you can see there's a higher volume, so that's after we've added the solvent, which is usually water. And then the red molecules are further spread out, showing that there is a lower concentration. You might want to also draw this in your notes, but that is it for today. That is how you make a dilution.